Hello and welcome back, Trademark. Okay, let's wrap up what I wanted to do last time. I wanted actually to have type errors highlighted. Sorry, it was too ambitious to do in one go. And also what I found out that our current language is too poor to really challenge the syntax highlighting, because the tokenization will really work fine, because for like old school JavaScript, which doesn't have multi-line tokens. So everything in the old school JavaScript starts on one line and ends at one line. Not everything blocks start, but they have a token here, token new line, tokens, if we want precise tokenization white spaces, then again new line, and new line actually spans two lines, but it lives on its line which it breaks, and then comes the closing brace. So it's not really what we want to highlight, because it's too simple. What we want to highlight one day, maybe today, maybe not, is a multi-line string. And surely one thing which is multi-line in even in old school JavaScript is the multi-line comment. What else can be multi-line? I think that's it, what pops into my mind. I think we should do the string, because they are interesting, and we also should try to make them syntax highlighted, and they will break, I guess. They will break our highlighter. No, they won't, current one, but the one we really need, which highlights only a few lines, it will. No matter how we do it, if we highlight the whole thing and then just take a substring, then it will be this magic codes for green, for example, then start of the string, then the string itself, then more of the string, then a little bit more of the string, and then some other code for the console which says, okay, that's it. And we want, let's imagine that we want more, and we want to just render these three lines, and they will be just white and black, because the actual markup will be lost, even if we do, I don't know, span, color, something like that, class, string. It doesn't matter how we actually mark the coloring. If we don't actually mark every character, which I did in the very first attempt, that would be like, okay, XX starts, YY ends, then XX, YY, then XX, YY, then yeah, then it will work, and it's fine. We probably can do this, but that's not really smart, and we don't want to oversimplify things. Anyway, in this video, I think we should extend our language, because the language becomes really boring, and I understood this when I was making a screenshot for a video thumbnail. I thought that it would be cool to do it like this, but without semicolons, of course. That just highlight me if you can. It looks good, sounds cool, plays with catch me if you can, because it's really hard to highlight, and highlighting wants to be to be caught, and we should do it, but gently. But what we have currently, we can highlight regular expressions because we have them in the language. We have division, but we don't have strings, even the plain old strings. We don't have keywords at all. We don't have lists, and that's like incorrect, but anyway, we don't have anything except numbers, and we also don't have function calls. We don't have, in the first place, IDs. So we cannot parse you, we cannot parse can, something like this. And this is probably not that hard to do, and I'll try to do it today in one go. Maybe it will be a combined video of multiple, but we really need to advance a little bit, because what is really cool to type check is function x, which takes y and then does if y, then return itself and then give it y again, or give it 1, and then else return string, something like this. And then you really want to have a fork here, and then understand that it can sometimes recurs, and then you need to have a lazy stub or something, or this empty set, something interesting comes, and we can then talk about it. But even the simplest one, if true, return 1 and return a string, gives us that it is actually a string or number, and that's good, because then when we have the string, we can have something like 7 multiplied by x, and it will tell us that, okay, let it be number or string, that's better. And it will check the union type, and the union will be, as you remember from our type checking video, that it will be some kind of object. Probably we will say, okay, it's a union, and it unions two different type objects, which is number and string, and the number will be checked against multiplication and will be fine, but then the string will be checked against multiplication. It will complain that, hey, come on, this expression actually is a number or string, and then the part which is string is incompatible or something. This is what we really want to do. This is good. And I'm saying all of this because it's kind of disclaimer. If you had fun watching other videos, you know that I really try to, trust me, to be not too boring when I implement things. So it's mostly like blah blah. It's more like talk show than coding show, so I don't really code that extensively. But now I kind of must, and I also gave the promise that everything you see in the code on the GitHub, you can find the video. If you know this trend of visual music, like Pomplamoose is the one very good example. They promise that every little they make songs, they sing and play every possible instrument. They promised that every single sound or every single instrument you hear in their covers or in their own songs, you can see in the video. And I really love this, and I thought, oh, this really makes me feel that I was there when they were preparing the music, as if I was their kind of friend. And I'm part of the family. I see everything. I see their old piano, I see their cool bass guitar and everything. So this is exactly what I wanted to make you feeling here, is that you cannot miss anything. All my sometimes broken train of thoughts is in front of you. Everything that I touch when I code, you see. Maybe the README I update without the video, but come on, README is a saint thing. We must always update READMEs. So my plan for today, and the disclaimer you understand, so it will be probably boring and long, is to have fun, chill, relax. It's good weather outside, so why shouldn't I just sit inside and code, right? And this is exactly what I want to do. And I want to first just parse strings. So I'll probably add time anchors in the description when where I say, okay, here I started string and now I start parsing, I don't know, if condition, which is a fun one to do. You know, you need to fold, so you really need to have priorities there somehow expressed. Then I do IDs probably, then if, and then maybe a function call with lists. because I really, really want to have functions to call them, because then we can really call functions. We can switch to closure. Do we have no? It's closure. What was that? Extend lexer pairs with conditionals, etc. And then we can actually implement closures. Closures are impressive, fascinating, groundbreaking, fundamental, whatever you can say, because if you have only closures in your language, the language becomes Turing complete. And who doesn't want to have a Turing complete language implemented, right? Everyone. So we can just implement closures and wrap up things, then write everything in the new language with just lambda calculus. Then would be amazing, wouldn't be? It's even worse than brainfuck. It's really worse. Anyway, but it allows abstractions, so you can have functions. But anyway, this is it. Strings. Okay, let's try saving this. We saved, and it just says expect token type and type div token. That's great, because does it work this way? Yeah, no, everything is broken. Yeah. All right. I know why. Because we cannot parse. We don't start parsing with value in mind. We parse with operator in mind. That's a mistake. You remember, and this is actually what is writing, that currently our lexer and parser together interpret the first slash as a div token, which is not, which shouldn't be like this. It should be just a regular expression. And this is because the parser, when it starts parsing, it doesn't, and the lexer also, the mode by default is undefined, I guess. Where is our mode? Where is next? So this is next. Next to. Oh, do we still have next to? Not good. Actually, I would say like should be okay. Let it be next to. It's also good. Mode, and the mode is here we have the mode. Okay, great. And the mode by default is not expression, which is wrong. So this is what we can have here, the mode, and we call next where? Yeah, the first call to next happens here, and then we try to parse the binary expression, which is good. So I think we should say that the mode x expression, and it will just work. Yeah, great. And then highlight me if you can, and unimplemented. What is this? Yeah, I know what this is. It's the it's here, unimplemented. Oh no, really? It's an evaluator. Yeah, it's here. Okay. Now it's because we don't have value inside. Oh, that's a good thing to fix next. Let's see. Then okay, strings. First we fixed the expression, so we can parse expression things one at a time. So I don't need to have anything else but the thing. Unexpected character, good. An unexpected character at source 1.1. That means that we need to go to the lexer. Super cool. And we already know how to parse something which is string-like, and it is a regular expression. Yep, this one. Very much the same, because we didn't parse the options, didn't implement options. So string. if character is actually this one. Yeah, for now only this type of strings, otherwise it might be a little bit boring to implement everything again. But anyway, can we? Okay, now I will say boring, but this is exactly the boring video for those who like parsing, parsers, and lexers. Okay, so this is it. We have start, the limiter starts here. So if actually it is not, then we just return null. Good, then we can unwrap this. It will be string token. Really? Do we say string tokens? Ah, yeah, we were copying TypeScript in the beginning, then I got lazy to always check how they call it. Yeah, maybe one day we can fix this. So I got lost. Yeah, if I yawn, that's okay. If you yawn, that's also okay. So here we have, we want the delimiter to be part of the string for now. We don't want to have it as a punctuation. It's all good. We don't check for the slash. And yeah, that's good. And while character is not a delimiter, then we just consume. Here it is. Then we consume it last delimiter. Then they have end position. Then there is a string token, and file start and should be just fine. So now we need to try to parse the string. And the string goes, we have white space, regular expression, or number, or string, or string. So, also good. The only difference is that we try to parse regexp and operator. Probably can we? Nah, that would be really great to refactor, right? You feel it too. Expected character. Yeah, so string should be fine. String. So we try to parse. And it's still there. That probably we just didn't consume it. Okay. If character return log, nice. Then we don't get into here. Sometimes it happens to me because the yeah I was too smart. So okay, so first the one string, yeah, we definitely need, and then another string. Yeah, so we definitely need to refactor this. At least. Just to do name me later. When I understand what I really want, I will, trust me. So here will be white space, no regular expression, number, string, string, and I would probably say that even like this, so it's a value. It's kind of value now. So is it expression? Is it expression? Huh? So maybe it is time to have expression which can be a string or a number. Let's see, maybe or maybe not. Actually, regular expression is also an expression. So that's nice. And the operator can be parsed only if it is not mode expression. I think that's the solution. I think that's the solution. So is it expression? So it is an expression then. Yeah, so if it is mode expression, it's simpler to say actually if mode doesn't equal expression, is not, yeah, then we try the operator. Yeah, that's interesting. So we just try operator, nothing else can be there. At least it is what I feel, and that would be cool to check. So I'll try expression or operator, and of course there comes the whole thing goes like this. Then we have white space or our hairy if, which we will definitely refactor. All of this is there already, and then end of line goes there. Operator is there, number is there, string, your white space is all there. Good, unexpected character. Still, that's sweet. Okay. Quick check. This gets parsed. Yes. Good. No. So it is always white space, or if mode is expression, then we try expression, which is number string. One of the type of strings. Yeah, actually I don't like this. I like string of type. Then there will be function string, which is returning string of type this one, or string of type that one, and then we just forget about it. It's completely encapsulated. Number or string, quite readable. White space, end of line. Good. Like it. Still unexpected character. Nice. So are we getting into here at all? Nope. Why? Hey, don't make me look that stupid. Because we don't get into the expression at all, I think we just get into the operator, because the mode should be more equal expression. Yay! You see, when you refactor, you understand better. Okay, so it is then like this. Let's double check if my assumption was right. And unexpected character, what? Space? Really? White space? Expression or operator? Operator plus or so really space, second white space. Does it return? If not, then return null. Yeah, when I read my code, which I wrote without trying to make it readable, I also hate myself. So white space, that's better. Good, so it actually does consume. So white space, we get into token, if token, return token, la la la. Then we come again, and then if mode is expression, expression operator, expression or. So do we really get it here? Yeah, we really get it. So oh, we don't have any more continue, so this loop we don't really need anymore. So we only do one step at a time. Yeah, I know I should refactor only with green green tests, but I believe in myself. So mode expression, good. Oh, too much Rust. Yep, that's it. So yeah, recently I've been doing a course on Rust, as you can see, and I pronounce Rust better than I pronounce JavaScript already. Yeah, I liked it. So if you like my videos and you trust me, and trust Stack Overflow. Rust is amazing, especially if you want to understand how they fight the restrictions they made. So as with Haskell, everything is immutable and everything is a function, and you need to invent tons of theory around it to make programs actually work, and they also have some synchronization primitives and this wonderful I/O monad and stuff to just find limitation to actually start writing programs the way you want to use a do notation and everything. Same happens with Rust. Rust also puts some limitation. You cannot have more than one owner and of value. Actually, even RC is not an owner, it's a pointer to an owner, hidden owner. And you cannot have data races, so you cannot modify the same thing from different places, not only threads, so which is a very hard restriction, but they have the whole library to support it, and even if you need an unsafe to do what you really want to do and you understand what you're doing, the unsafe area is also quite safe. So we have multiple layers of unsafety. So yeah, it's amazing, and it's really mind-bending and blowing, especially for a garbage collected person. I'm a garbage collected person, worked with garbage collected languages since forever, since C++. And even in C++, we were trying to code everything as if we had reference counters and stuff. So we tried to never understand and comprehend the full lifetime graph of our programs. That's not possible. Okay, that was a lyrical note on Rust and why I cannot see return as a mistake anymore. Great, so it is working, and it will interpret this as an unexpected character slash at source11 because by the way, why? Expression is, yeah, and regexp. Number of string or regexp. lost in translation, lost in refactoring. Now it works, and it does its job kinda right. In real JavaScript, I guess it won't work. So we say that let x equals foo, then it's good. Then let y equals, and then we don't close it. Consider invalid regular expression missing slash, so we probably should do the same. Or should we? Maybe, because currently we ignore the \n there. We should probably not. Should tell it that if it sees the new line, that then it bails. But nah, this is definitely for later, otherwise I will never finish this. Anyway, you feel I'm relaxed, I'm not rushing, I'm having fun. Good, so this works, and then this should also work, and it works great, unimplemented, that's fine. That's nice. So now I say that while we have all this, so we should have strings too. And expected token, I got string token, yes, good. This is what is expected, because our binary expression can have value literal, and value literal can be one of numeric literal or regex token. And now we come to also having string token. Doesn't sound good, doesn't sound right. So string token, and it's not actually a string token. No, it is. It is string token. It should be simple string, I guess. Oh, just string. Let it be just string. So it is string. Bam, great. And in where? In eval, right? Oh, in type check we have unknown type. That's fine. That's fine. That's fine. JS. We currently cannot highlight. No, we can highlight. We cannot do type checking, and we probably even cannot evaluate. Yeah, and we cannot. Now it's in evaluate. Yes. This also we cannot do for now. Otherwise it will explode. And highlight is forgiving. You see, it doesn't care about this. Color. So maybe we'd go to highlight and do string, and let it be also as regular expression, and it just simply works. That's great. So token, nope. So maybe I can do this. Code slash w, and there was what? Closure? No. There was event. I forgot where it was. Anyway, ANSI colors. Nice. Okay, green is 32. 32. Green. Done. Yep. It works. Just like that. And look at this. If I put two strings, it shouldn't work. It should expect operator here. Yeah, unexpected character. Bam. Why? Because we cannot parse it. This tokenizer can parse it because it is loosely implemented tokenizer. But that's okay for us because we're not trying to do everything. And if I then just divide 1 by 1, and that is good, then it's good, okay. Now that's a valid JavaScript. Actually, yeah, the parser should be very forgiving, and the TypeScript parser is quite forgiving. Even if you have a syntax error in one place, it will try to compensate for that and still give you the opportunity to see more syntax errors than just one. Currently, we don't do this because it's a little bit too scary for me to implement. Yeah, all good. Strings. So highlight me if you can, right? Highlight /me. That should work already. Yeah, good. So strings done, some refactoring, and that means if you did some refactoring, then add strings and refactor Lexer a bit. Great. So what else? I think the next step would be just parsing an ID. Or better probably we do semicolon. Because what I want to say hi here, and I cannot because it expects an operator here. Yeah, maybe that would be great, and it would be an example of something which repeats. Yeah, let's finally do it, and I finally can stop pressing Command KS and just save it here. That would be great. So it is very, very, very simple to do in the Lexer. Anywhere we can have semicolon where it is not actually anywhere, I think. So white space or semicolon, right? Google. No. Semicolon. Yep, all good. So go to white space and have here another function called semicolon. And it's easy if nothing is easy. Nothing is easy. Because we need start, we need end, and we need return type. Yeah. Good. Okay, so start is there, all fine. So if character equals semicolon, then if it doesn't actually, then we just return no. If it is, then there is start. Then we read it, consume it. Then there is end, and then there is a semicolon. Oh yeah, okay. File start end. Good, bam. Expected get semicolon. Nice. And now, first really funny recursive thing. Okay, not the first, multiple expression. All expressions domain. Candidate to that. So we don't have binary expression anymore there. I guess, first of all, it's not binary expression. I guess it should be an expression now. So we abstract it a little bit. An expression. And we just return binary, so we just rename it for now. Expression, binary expression. So in here we just have expression currently, and what we really want, we want to have a statement function. Statement. Yeah, and statement is actually something like expression and then semicolon, actually optional semicolon, and then expression as many times as we want. So how we do it? A statement must have a semicolon, so but it doesn't really need an expression. So it's something like this. So yeah, expression and then semicolon in the end. Sometimes, yeah, something like that. Yeah, anyway, so we try to have to parse an expression first. Const expr equals expression. That's amazing. If we can, then we should add it to the list. So again, const expers equals then we do expr push expr if it is there. So something like if expr, then we push it to the expr, and then we do what we do. We do try to parse semicolon. And how we do this usually? Other helping functions like okay, next value plus token mul token deep token expression. Did I add it? It's nice. Take is there? Nope. So I think it is time to add take. Is there actually? Maybe I just okay, take type. Then if token type is the type, then we do token and we do just next. Okay, next. And then mode, we would need it undefined actually. What I'm doing, yes, just mode. Yeah, do mode, and then if not, we return this. No, maybe take because it tries. Do we really have maybe here? Not yet. Okay, maybe take, that's enough. Binary expression, nice expression. So we have then if expression was there, and we also do maybe take semicolon, and it should kind of work for now. Statement. And then bam, we just return expers. Expected token type and the file semicolon. Okay, because we don't do statement, we do expression still. So, and will it be next expression? Then, actually, maybe this depends. If we're within a body, then yes. If not, yeah, we will need to play with this, because if it is expression, sometimes function means a function statement or function expression. Yeah, that's for later, and it's quite simple to implement. I remember it was just one if. It is simple. So now, all good. Then everything will just explode, of course. Expers, push. Oh, no, it doesn't. Okay, JS, hello. And we have AST, and we want to log it with dir death, yeah, something like this. Result, evaluate, yeah, this is what we want. We want our dirty AST exposed. Bam. Great. Is it what? it is yeah, it is an array of one thing, string div token, and then source, and that's it. Yeah, the another one gets pulled but doesn't get consumed. That's interesting. So maybe take semicolon. Yeah, we take semicolon. If we don't do this, what happens? Syntax error. Great. Then after statement, we have this. Yeah, and this is fine because this thing gets consumed by parser itself when we want to get end of file, and we get end of file. That's great. That means if we have anything here, like 1, 2, 3, just break. Yeah, great. That's nice. Predictability. So, then let's do 4 and do this. We try parsing it. If it is there, we try consuming it and pushing. If not, this is it for us. And so now it is one statement. Oh, this I made a mistake. It is one statement. It's not multiple statements. Yeah, so this goes away, and we just consume one statement. Should be fine. And here we really want to have a semicolon for now, so it's maybe take. It's good. Let's have take. And if not, we actually throw. Do we have this throw somewhere? Expected token type end of file. Do we have, yeah, expected? Yeah, this one. Yeah, we really want to have a semicolon everywhere. So for now, let's not have optional semicolons. It's too much for one session. And it's an interesting topic to add to an existing working parser with no pressure. Expected token type. Yeah, actually take, yeah, token type. Yeah, we should probably have type as an, yeah, for now it's fine. Token type, we will use a list later. Got token type at where should be. So now we just explode if it is not what we expect. And yeah, all good, all good. So all and every statements must be wrapped with, ended with semicolon. Sorry, old school Peter who hated semicolons. Now, after half a year of Rust, I like them because they play some role finally, not like in JavaScript, where they also play role. Yeah, sorry. So, what we do, we have statement. If there is statement, then we do take the semicolon. Okay, if not, we just return null. That's easier. I return null. That's maybe statement also. Expression, we parse expression. Then there must be a semicolon. And then we actually return the expression. Good. Yeah, all fine, and it's just one. Then statements. And what we really want, we want to have statements. How we do it as we want it. Const. Yeah, and then what, for loop, then const statement equals statement. If no statement, then break. If yes, then statements push statement return statements. Expected character 1. It's already something. Because of the mode, of course. So when we try to parse statement, we already know that the next must be of type expression. Can we actually move this away? Yeah, so we have statements, and then statement want to parse. We need to move. Yeah, and we come to the same problem again as we had before when I wanted to have a more smarter parser. So yeah, we want to start always with, okay, we must start with expression currently because it is always guaranteed to be expression. And then when we move here, take semicolon, then I know that after semicolon it is something which should be an expression or some closing character. So we need to give here expression to the take. So the mode, the next mode, when we do next, needs to be, yeah, that's not as beautiful, this mode, as I wanted it to be. So probably we would need to flip the logic, but later. And that would be what's stated, you don't know it. Bam, and it just works. It parses it. It has this wonderful semicolon, which we can also highlight. Sweet one. Comment token. Yeah, as comment token. So it's semicolon. Yeah. So because they are not that important. Nice. And now we have numerical literal going right after that one. Can I please? Yes. Source. For simplicity, 1, 2, 3. Save it. And we have 1, 2, 3. Great. Great, at least we can have now semicolons. Great, finally. Forget about syntax errors because of semicolons. Add support for strict semicolons. Great. Now, finally, IDs. Foo. Unexpected character F. Great. So that's even simpler. IDs start with a letter and continues as number or letter. And they should be the, okay, maybe not very first, but something like this is numeric, and buffer, yeah, this is it. So ID, start position, if is numeric, and want is alphabetic. If it is smaller than A, smaller than Z, or it is smaller, smaller, bigger than A and smaller than Z. Yeah, is alpha. Great. is numeric. Actually, not like this, but something like this. So first start position, no. If is alpha. If not is alpha, then we do return null. Now we know that it is an ID, and we consume the character. Const start position. No, we do start here, start position. Then while is numeric character or is alpha character, we just add it to the buffer and do next. And the last one will be always there. We don't need this check. So, and position is always there, and it will be ID. And the value will be just buffer, because it's a string already. Should just work, then bam, unexpected character F still, because what? Because we need to add it to our wonderful expression. So it's number, string, regex. What we have more than numbers, strings, there is, we have actually IDs. IDs are the best. And bam, all fine, expected token in the file, and we see that this is our wonderfully context-aware errors. And really, parser doesn't really know about them, because that's true. Our statements, a statement is an expression, and then the expression is a binary expression currently, which is a value literal there. And value literal can be something like this, and that, and the first one goes an ID, and then bam, it is an ID, and then again highlight ID, so it should be somewhere here, and ID becomes this, let's see, green, yellow, blue, yeah, blue ones. I like them blue. Here, see, they're blue. Okay, good. Yeah, it was quite easy. Noise. So we now have just IDs. We can multiply them by some number, and it just works. Yeah, very nice. Very nice. So what else can we do? We should have a nice commit message. Add IDs. What else? Maybe we want to have a function call. Maybe that would be good to implement right now. And then the conditionals. No, first conditionals, I think. Function call is a little bit harder. So actually, if you can. And then unexpected character, this. So this is it. If currently is parsed as just an ID, which is not really. So in Lexer, when we parse, and in JavaScript is actually special case. So if we know that we are in expression position, we shouldn't. But in our case, expression is always like an expression. We cannot start if, because we always start with an expression. So currently I will not implement this corner case where you can have some of the operators as not keywords, like x let, and you can even call it, because let wasn't a keyword for a long time, and it was just later implemented as a keyword. So if we are within actually let x equals 9, even in the old school JavaScript was a syntax error, because here should be something in between, some operator. So that was a safe introduction. But here we would need to not look for ID. So we can have like one type of ID which start in the expression position, and another type of ID which is a function call, like let function call. And it should actually probably work. Let's test. Node function let good, and then we just call it let. Yeah, it works. So it breaks the tokenizer here, but it actually works because it will be implemented later if it doesn't have any additional meaning, and that's kind of tricky, and we will not do this. We will just implement the modern JavaScript. It's still a modern JavaScript, but like only modern how we feel it. So how I feel it. That's enough for one a stream. If you can, la 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 la, all good. Save, and then if needs to be somehow treated as a special case. So const key words, and we have there oh you not set, and there will be if. So then we have this value actually in the buffer. So if keywords has buffer, then it is a keyword. Otherwise, it's just an ID. And it is important because the keyword ID is important for us to tokenize it correctly, and then to simplify parser's job. While in the wild, we would need parser to actually make the decision if that was an ID or it was maybe an ID. So I guess we had to, that maybe like we try to parse function maybe if some, or maybe let in that case, maybe let in that case, and then it tries to have const keyword, and then it just gets ID somehow, and then looks if there after this there is an operator, then it treats a keyword as a keyword, so it lets so ID let. Then it is actually a keyword, maybe keyword, then if there is an operator it's not, then if there is an paren, then it is, oh it's not again, but if it is the next one, like const next equals ID again, then it is actually a let, something like it's like it's nice, and but it explodes in my mind. So we do it here to help our lexer, tokenizer, highlighter, and parser to just not think of it, and we will not either. So what we have, expected character. So how we do it? It will be an ID. It will be keyword. Oh, we just, yeah, and keyword type. Maybe we just have if. That might be good enough for now. Why do we need an operator, or why do we need a keyword of some type if we can have just a token of this type? I think that's like good for me for now. So it's just an if, and in the parser we can have then here statements, and then a statement, and a statement can be an expression or an expression expects what? So binary expression value, yeah, it will not parse it, and an expected character. Okay, great. An expected character. Oof, oof. Yeah, so it's not only this, we also need to go to semicolon and say that we also want to have, if character is this, how's it? Parents. I was always bad at it. Braces. Sorry. Braces. Oh no, not this one's. Oh, very good. Parents. Okay, parents. Square brackets. Good, and parents. No. Yeah. No, not parents. Parents, guys. So brackets, square brackets, parentheses. Okay, so parents, they're still parents. That's why parents. They will be. Then if it is an open parent, sorry, then we just start it, we consume it, and then we return this type. Open parent. Good. Okay. If it is closing, an open close parent, then otherwise it's just null. No. So they also go here. In our, it cannot be an expression. It's not an expression anymore, and this is why I need to rename it. It's not really. Yeah, ID, then a number, parents even used, so good. Unexpected character. Source 2, 4. Oh, maybe because we switch to the mode. Expected. Yeah, so this is where we need to maybe even go to parser to tell the Lexer that it should not parse. Yeah, probably I will simplify it. I will just tell that expression and operator, this is not actually expression. Maybe it's a value place, something like that. And ID kind of, and then parents don't go here. They just go here. Always. Doesn't matter what it was. Yeah, that's better. And is not defined. Sure, probably here. Start, next, end. Start, next, end. Way better. Expected token type semicolon, got open paren. That's good. Now we are in parser. And here in statements, we try to parse expression, and it actually so it tries to parse if as an expression while it is actually not. So currently we can tell that if is an expression for now, maybe, and instead of trying the binary expression, we can have, yeah, it's not an expression, but how does it consume if. Why does it consume if? It should be exploding at this. If keyword has buffer. So do we hit this thing? No, because why was if set? Okay. Are we here? Yeah, but we're not here. That's it. Okay, why? Buffer. Yeah, buffer F. So it's okay. Because I don't add it to the buffer at all. No, it's nice. Yeah. So before reading it, then bam, if, and then unexpected token if. That's great. If here. Yeah, I don't write tests, and that's so bad, right? But yeah. So I always tell everyone to do testing, and I don't do it myself. It's a bummer. But yeah, sorry. Now we have if, and we don't know what it means. So that means that a statement can be an expression, or because yeah, an expression followed by okay, this goes here, followed by a semicolon. Okay. Or can be an if which doesn't really require a semicolon itself, because this semicolon will be eaten by the statement within. So if it is something like, oh, let's do only this for now with now let's do this is more funny, and it requires some context. Yeah, so this is a statement. It's good. It's not an expression as in Rust again. Yeah, I always wanted to have something like let x equals this if la 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 else. I also wanted to have it in Ruby. It's the same, but in JavaScript not. Too much C. So now we should try to parse if statement. Yeah. If statement. If statement, we just return if statement. There should be no if statement. Nothing else there. If statement. How does if statement then work? I would say that if statement works like this. It tries to get maybe take, I think, const keyword, maybe take if no keyword, then there is no if, return null. If yes, then throw 1, 2, 3. Are we there? Yeah, we are here. That's great. Otherwise, like we got end of file token open print. Yes. Then we always know that the next one must be the take. How we called it? Open parent. Yes. Then in our case it will be always ID, and then take close parent, and then actually parse a statement, right? Yeah. So for now, should be more or less okay. An expected character y, where u, okay, so we do open parent, then we take id, open parent, does it actually move? Yeah, if character is, then we start, we consume it, or if a character is closing, parent, is close parent. Okay, do we get into here at all? Yeah, so it's a draft. It's a draft. This will stay, but here we should of course parse something, something like expression, because here it can be if 1 plus 2 equals something like this. Yeah, it is an it's an expression. Yeah, equals is an expression. It's not a statement. But we know that there will be an ID, and we just take ID. And were we there? Nope. Open paren. Good. Yeah, I see that. We can have this, but not open paren. Why? Open parent. Let me check the time. Okay, so we will debug it in the next, not in the next video, in a minute for you and probably tomorrow for me. I'll try to glue this seamlessly. Okay, I'm back. I watched the last few minutes, so it should be fine. Yeah, so we cannot parse for some reason expect character y. I think it is this y, right? So we say x, then expected character x, great. And expected character means that it is completely unexpected. But it shouldn't be. And I think this is because we're not telling that it will be an expression. So here in parser, when we take open parent, we should give it the mode that the next one will be an expression. Yeah, I think this is it. Oops. Minus. So I think this is it. And we say expression. And expected character C, which is already better. Yeah, you can. That's nice. And we do it exactly like this here. We know that in our case it will be an expression. And it just parses. Nice. That little break straightened my mind a bit. But here it's not actually an ID, it is an expression, which is quite interesting if it will just parse. Is it so? Oh, so it can, expression can say no. Can it say no? Binary expression, it can, it's maybe, alright. That means, but we must have it there. So we'll insist in our if. Okay. Where I'm going? No. I'm losing my mind. So here we say that okay, so we say that const condition calls expression if not condition, we throw our wonderful syntax error called add expected expression then yeah, I guess it is time to say that we want to throw new syntax error. Okay, and I'll call it probably panic. Somewhere here, but a literal function panic, and here will be message. We will just throw new syntax error with the message. So actually message at so panic, show me where is the log file used a syntax error. So syntax throw new, okay. It's the same, yeah, so we should probably panic. Got token type. Quickly, because yeah, I really cannot see this anymore. That was one. Yeah. Syntax error, actually throw, interesting, throws. Syntax error, so panic. Expected token type. Got. Okay, panic. Nice. Throw. Token type, also can use it here. Panic. TS ignore. Interesting. We were doing something with TypeScript, that's great. Sorry, I don't remember that. Expected token type and at where we want it to be. Okay, and throw. That one, next token is undefined. So I think we can panic even there. Before, so panic comes. No, we depend on token. Yeah, token location. But we can still say that next token is undefined. But yeah, we don't know where it is coming from. Good, that's enough. That's good. You can, it just works. And I wanted to make if only compile if it has statement. Here, if not, panic. Expected and expression. So if we have here plus, for example, unexpected character, and then because we don't do this, works, but if I don't have anything here, expect an expression at source to, yeah, it kind of works. Sometimes it's really amazing. It's really amazing. Okay. So let me think a little bit. Should be fine, and now we want actually to return an if node. Return, how do we do this? Can I steal a little bit? Yeah, so node is something like this. Okay, return. So now, for now we don't do else, that's okay. So binary expression, conditional. Yeah. And we have clause, right? So it's not condition. Okay. if statement. Let's see. If statement is for a conditional statement, that is. Let's see the proper naming. The value is number one, so it's too primitive. Okay. Statement is specified. Condition is truthy, so it's a condition. So it's falsy. Another statement can be executed, so it's a condition. And the second one is its condition is truthy. Okay. All right. Good. So now we want to have a condition in this case. Okay, it's not conditional, it's if condition, and then actually this is our then, right? And can we do it like this? That would be amazing. And then we just have condition, no, then location would be key. So the if statement starts with the keyword, the start of the keyword, and ends with the end of the expression in our case. So with a semicolon. So it should start file keyword log file, then keyword log start, and then the then log end. Yeah, should be fine. You expected an expression at, yeah. So if true, no, if actually one, bam, it's there. Let's see if it is really there. Binary expression, da 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 da. This we don't need. Let's make it simpler. So, oh yeah, type if. Yeah, every time it really feels like magic when, and we will add else, and it will allow us even have nested else in like 5 minutes. Yeah, when you have a good framework kind of helps. So then we have ID, and in condition is type numeric literal, value is there, ID is there, and actually we can have here 1 plus 1, and it will still work. See, it is already looking like something serious. The condition is binary expression, so we can evaluate it and check if it's truthy. Yeah, not bad. If x plus 1 multiplied by 0, so it's a binary expression is x, id, x. Good, I like it. And then the canon, and then as id, can I also have like 1 plus 1 here? Will it work? Then is a binary expression. So yeah. And now let's see a conditional if 1, 2, then if 1, if 2, then a foo. Oh, it does break, so I don't need to debug much. So there is an if, and in its then there is another if, which has in its then the value id. Yeah, that's great. This is amazing. So so sweet, so sweet. So we have conditionals, at least without else. That's even nested ones. So I would say that it's a good moment to do some comment. Add basic ifs. Brilliant. And then we should add then.
So if one x, else, so if else, and then we should x, and else it doesn't know, unexpected character e at there. This would, okay, maybe not 5 minutes because we have this problem with expression, non-expression. Yeah, that's a bummer, but let's see. So if statement first, we should parse else. Maybe it will just magically work. Or we had if. Oh, we had plenty of ifs. Yeah, here is if, and then we have else. Keywords, but it will still complain because sure it's in next to, and where it is in this parse next, and it's actually in yeah. So expected character it serves. Yeah, because it is here and unexpected character, so it didn't parse, and it is because we were in mode which doesn't parse IDs, and then mode, not node, mode, and well, last one was undefined. Okay, good. It's expected, so that's a design flaw in this case. But I know I'm cool, calm, because I know that it still will work. Maybe I had to add more ifs there. So currently, if our if statement is we do expression here, maybe take if, then we say next one is an expression. Okay, can we have not expression after this one? We can have if we say that if this, then we don't have else, for example, and we just say that this is it. Then we will parse semicolon. And this semicolon is always there in the lexer. Yeah, even in mode expression. So it will kinda terminate the expression. Because it's a semicolon, isn't it? Yes, great. So in this case, I think we can safely say then when we parse our expression, and we cannot, right? Close bracket, then we have a statement. Then is a statement, while then should have been an expression, actually. Expected character. So like this. Expected, sorry, semicolon. Aha! Aha! So that was a mistake. Okay. So it shouldn't be. Statement should be an expression, and if must be, in this case, must be part of an expression, because currently it is parsed as an expression. But that's fine, because we should go and set statement. So statement is an expression, and then an optional semicolon. Maybe take, yeah, I would say like this. If statement, then we parsed it, but it's that it is a statement, so it should have done it itself, right? Yeah, that's a question. So we maybe maybe take semicolon. Then it just eats it and it's fine. Yeah, it's a little bit stinky, smelly, but yeah, it was perfect. And this is, again, it's not super fun to do it completely well designed. Then we need to add more corner cases and really refactor. Maybe later, maybe if you write in the comments that, hey Peter, sorry, my mic got jammed. Hey Peter, you should probably think of refactoring because this mode is, yeah, and there are some ideas, maybe you can do this and that. Definitely, why not? But for now it kind of works well. Well, it works, it's fine. I expect the character E, yes, great, because the parser says that it is an operator. So I know that I wasn't that distinct if it's an expression or non-expression and only parse ID number and string and regex. Actually, I only did the distinction between regexp and division, and it was simpler. Here I wanted to be a little bit more strict to myself to find the limits of that idea of having very strict communication of what can be parsed next. It kind of sucks. It requires too much attention, too much of this hinting to the lexer. But anyway, let's try to continue. If not, we will give up on that. So semicolon, it works. It doesn't parse lex because when we, maybe it is time, yeah, let's see. So if statement is there. Yeah, actually for now it's if expression. Yeah, so let's not lie to ourselves. So if expression have then, which is an expression, and it doesn't really try to parse IDs at all, and expression, oh, it will be very hairy because expression have very long tail of possibilities, and we would need to always guarantee that the last one, yeah, that's a bad design then. I really don't want to do it this way. Sorry, microphone, please stay here. So yeah, I give up and move ID at least out of there, out of here. And we know that ID cannot be misunderstood, yeah, somehow. So it's not, it's a value then. And we try to parse white space, semicolon, ID, or semicolon, parent, then the value or operator. So actually it's simpler to say when mode should be operator, not expression, in most cases. Yeah, probably this would be a good idea for refactoring. So to do, maybe switch lexing mode from expression to operator. Yeah, that might be a good idea. And it still doesn't work. No, it does, but it breaks another. So expected token type open parent got ID. That's very true because yeah, I did this funny mistake. So I guess we should have a map of if to type if and then else to token else. So keywords, then if keywords buffer, then the type is actually const keyword buffer, if keyword, do I have type here already? Nope. And then easy, then type, if type, then type, then it is expected token. So I got else. Nice. Now we can do what we want to do. We've got the then expression, it's mandatory, and we need to check. Yeah, if not, then let's try first to do it. What will it tell us? Cannot read property log of nowhere if expression. Because yeah, and that's the place. So we need to panic if then is undefined, expected. Yeah, good. So we've made it. And TypeScript would say that it is node or null, and that this cannot be null. It will just scream at us. Panic. So we're panicking. Now we can try to const else keyword equals maybe take else, and if we have else keyword, that means we must also have the else, const else is expression, else expected expected condition expression for condition, expected expression for then, expression for else. Perfect. So else can be null, which is good. Let else be null. Then else will it work? Then else unexpected strict mode reserved keyword. Yeah. So else, then else, LC maybe. Yeah. So else. Expression. So this, okay, expected an expression for then. Yeah, good. 1, 2, good. Then else, expected an expression for else, 3, unexpected character 3. Interesting. So maybe take. Does it actually take? If token, then next mode. Yes. Of course. When we do take them, maybe take else, and we should have mode expression. Yeah, this is definitely bad. We should have expression almost everywhere. Good, and now it parses. So it complains, It doesn't complain, and it doesn't require the semicolon. Yeah. Noise. No doubts. Is it really? No, actually, in JavaScript we must have it here, right? If, and there is a statement. Ooh, not an expression. Yeah, this is why. Yeah. Okay, I think we can fix it slightly later. So, highlighting. We have ID, we have numeric semicolon, we have open parent and close parent. That's really good. Super. So what's next? What's next? Would be adding if and making it red, I guess. So if should be red, maybe it's 0. No, it's 1. Yes. Or maybe it's 5, 7, 8, 9, 4, 3, 2, 1. Okay, also fine. It's a bit dark, but I don't want to tune it. So it understands that this one and else, they are keywords. I'm looking here. That's amazing. That's amazing. So good. And if we have a semicolon there, yep. What could I wish for? More. Now, I can have, hopefully, at least here, else if 1, 2, 3, 4, 5 should kind of work. Nope. Expected an expression for else. Aha. Yeah, sure, because it's an expression for else, and we changed it from statement to expression. That was my mistake. So yeah, I have to parse it slightly later has come. Okay. So what I can do is say that it's not an expression, it is really actually a statement which has all this stuff. So then so this is an expression, while this is a statement. Then is a one single statement as if it was in the beginning of the string. And then else is also a statement, and bam, it just doesn't work at all. Expected token type, semicolon. But else, actually, not bad. That's maybe good. If this else, oh, yeah, it works. So sorry, prettier. Maybe we want to still have it like this, and check. Yeah, sometimes you need to fix a bug so that the well-designed language syntactically works fine and you don't invent too much. If numeric literal 1, then numeric literal 2, else if true, condition value 3 numeric literal, yes, and then type numeric literal in then 4, perfect, and then else value 5, which is also quite true. And then the location is cursor 0, and then all should be there. Column 9. So is it the first if? Yes. And line 1. Start, okay, line 1, column 1. Yeah, and I don't believe this. 1 and 9. No. Cannot be. Ah, yeah, sure, it is. Because we're taking the then or else, so it should be. Okay, so where it is, yes, there is the end. Const end equals else, then else lock end, otherwise then lock end, and then, and yeah, let's check. Line column 32. Good. Yeah, so it stops here. Well, it shouldn't, so let me check. Parser. Dear parser, you ignore the semicolon in this statement. So yeah, I fixed the bug where we ignore the else in our position locations calculation. All good. Statement identity and statement, then we take semicolon and we just return expression. But yeah, that's true. We should actually return statement node. I guess that would be nicer. Then it will be completely correct. One statement second, so it's not just naked expressions. So return. Take semicolon, which is, yeah, const semicolon. So it's a statement and it has expression, then why not, right? Nope. Yeah, stop it. Okay, then an expression. No, and then file expression log, start expression log, but end would be semicolon location end, right? Good, and that means now we have line column 33, and it's column 33, yeah, so the whole thing, if we have a bug in it, it becomes an expression, which is, so else is a statement, and in it has an expression. Nice. Yeah, good, because there will be also a list of statements when we have a block. And yeah, so far so good. Looks like JavaScript has ifs. Great. Let me see if we can already parse what we had there in the very beginning. If you can, yeah, we can highlight me if you can. What's left? We have conditionals. We don't have yeah, we cannot really call anything. Can I? Yeah, maybe for today, yeah, it's a little bit longer to fight with it. So I think we've advanced a lot. Maybe I will append something to this video tomorrow and just concatenate it, but still we have ifs with else's working well. That's very nice. So if we do, if you can, it breaks. Good. Yeah, I think we should add function calls and actually function id open paren, then id list, and then a curly brace, and then just block. Yeah, and it's a block, right? So it's a block. So just block. Function id. This one is id list. Yeah, something like this I will probably do. So I'm giving myself a hint, and this is actually quite simple. It's id. It's a keyword. We just say it's exactly like if, almost. So it's a statement by itself. It's if statement. This is an if. There is an if expression. Yeah. Now it is statement. I think it was if expression. Now it is if statement. Yeah, because it has statement in, and statements don't return values. And yeah, so I'll be back in a second for you, and probably a few months for me, but hopefully not.
And I'm back a few days later. So function ID, ID list block. So yeah, we can continue, and it is in a statement. So we can quickly do something like copy paste of if statement and see if we can simply ID list list. So we would need to have list, and we didn't do this kind of list. Okay, let's start with something more interesting than function call with an action function. Yes. So if statement. Ooh, yeah. Finally, we are coming to something very big. Function statement. So function statement is not a functional expression, right? So it doesn't return the function itself, just creates it in the scope. It's like not let, not var, it's something in between. And we want to maybe take function. If not, then we return. Then we want to get an ID const, so let's copy paste that. So we've covered function, and it's a keyword, right? So yeah, we would need to teach our lecturer to understand that function is a keyword, and it's easy because we've done it. How's keywords? Yes, it's a constant. Keywords, and we will have function be function. I think should be fine. Yeah, expected token, end of token, that's good. So, and we will have here an example function foo, which takes nothing for now, and it has a block which says 7. I think that's already enough. Expected token type in the file, got function already good. Lexer is already doing this. Very cool. And this one, we just do it like this, and then here we just throw 1, 2, 3. We add functional statement where statement should be. So we have more dynamic statement, if statement, and this is so statement can be something like this, or something like that, or in our case, maybe it's a fun statement. Maybe it's a function statement. If yes, then we just return it. I think that should be it. Will it? So yeah, we have if statement, which so we have here a fork based on the keyword. So if it is not an expression, and currently we're trying to parse an expression, then what is it, right? Probably we should move these up and have higher priority. But anyway, once we have a problem, fix it. Final statement, Peter. Oh man. So we have this. It's kind of switch case here, right? We try to parse expression. It tries to match it. It's kind of smart matcher. If it matches, all fine. We just know this is it and we return. If not, we try this one. If not, we try this one. And if not, this one. It's kind of, and we use the keyword as here as a discriminant for the kind of union or something like that in our source code. So here we have like different types of lines. So this line is just an expression, this line is not just an expression, it's an if statement. Okay, it's a statement, but inside it's just an expression. And this one is also a statement starting with function. So far so good. This is why I keep adding it to the statement matcher. Function statement, yeah. And let's see if we throw. We throw, great, so we're here and we can continue having fun. So we've matched the function. We need to take ID. Right. And then will happen an expression. Well, let's see. Const name equals take ID, I guess. Let's see the name and throw an implemented. Do we still have it? No. Okay, then throw 1, 2, 3. All right, that's not bad. We are doing it. We're parsing it. So ID and then open paren. Then let it be just one ID for now. I guess it's not the ID list. We'll do lists later. Just one ID and maybe one ID actually. Then we have this open paren, which is important. Then we have an expression there. Can we have an expression? Actually, something like a equals 1. So it's more complex in the modern JavaScript. And this actually a equals, and here starts any expression, but the left part must be an ID, and only ID. We cannot say this, right? So yeah, it is an ID. For now, it's just a. And we will parse it. Okay, I'm moving here. Open paren. It's not a condition. It's maybe arg, and we should take another ID. I actually like that we have this take. Probably should rewrite the rest of the parser in using these idioms. Maybe just one arg1. If there is arg1, and there is not, we don't actually care. Then we try to have close print. Then it happens block. And the block is a block in this case, and we should know how to parse it. So as a block, we take open curly. Then happens a statement. Yeah, that's cool. And happens a statement, at least one. Const body calls a statement 1 or 0. So that the block will handle the multiple statement. We already have statements, right? We should have statements. Yes. Reusing. Building upon what we already have. A body is statements. And can it be 0? Yes, good. Nice. I like it. And then we will have close closing curly, and that should be it. We just panic, and we will just unexpected character. Yeah, all good. We don't have open curly, and yeah. Where did we have them? We had punctuation. Oops. Parents, right? Okay, that would be easier. And we have their parents. Yeah, all good. I think we can join this family of parent parser flexors and open curly and close. Close. Yeah, all good. Yeah, now we're there, and we can just return, I think, right? We need to const close, because we need to have end and begin, and keyword we also need to have. Yeah, all good. At least I think so, until it all explodes. Yeah, and when we have a block, we will move this one out. We can have a block and extend our if to take here block or statement. And then it will just work out of the box. And here at this level, you all, I don't know how to say, it's like use, I don't know, yeah. You see people that it's cool because we're not really touching the recursive parts that much. We already have a machinery to cover it for us. We just define things using these building blocks we already have. This is the beauty of programming. We don't need to repeat ourselves too much. And it all becomes, this becomes addictive. So it is very repelling to start with Lexer, especially if you've never done it before. It's really uncool, and you like need to cover all the corner cases. You think it will, the burden will never end. But actually, if you spend just 1 week writing one Lexer once in your life, hopefully in the university, then you are free. Then you copy paste it, change some syntax, and you already can start playing with your language. And it's highly addictive because you control everything. If you never like that, I don't know, function is a very long word, you just say fn and you're rusty, and then no one can stop you. You change everything. It's super addictive. And we planned to have macroses. If I don't remember where is macros, I meant something complex now. Macros, macro, oh, okay, yes, maybe not maybe, actually, that would be cool. After closures, we can try to do macroses, and it's then just amazing. You can write, if we will have a complex enough language, we can define the language using the language itself, at least to some extent, and then, trust me, you cannot stop. So yeah, I can, because I started doing when I was already over a decade into profession, so I have my different habits. But look how amazing it is to build your own language environment, and yeah, super cool, super cool. And we're doing it using just plain old JavaScript. We don't use anything fancy. We even replaced an iterator generator with a function call. So imagine if we had all the modern tools which automate lexing, parsing with just regular expressions. It all compiles down to very efficient code. Bam, you can create 1,000 languages in the time we created just a tiny fraction of one. But anyway, this is still amazing, and I cannot stop having fun with that. So function. Function, in this case, it is important. it's function statement. That's important, because we will have function expression, which means that it just returns, and we need to have a left-hand side on somewhere on an equality operator or something. Okay, then we have a function. We have args, and currently args const args is just arg1. Then we should have a body, and definitely name. Name is already there, and it's an ID, all good. Then what do we have else? We have the keyword we don't care. ID is there, args, and the body. And the body is this statement. Okay, and location starts with the keyword start and ends with close lock end, I think. Right? Yeah, it starts with the start of the keyword, then tokens, 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 tokens. Last token is the closing curly. Good. Close, close, close. Unexpected token dot, because where here, because yeah, start end, and then just works. Yeah, now it is really easier to parse things and say type statement, all good. Binary expression, okay, let's simplify it. And then bam, function statement type name ID full. It's so sweet. Args just one with ID a, good, good. Body and its statement 7. Let's see if I can do +9. Of course I can, because no one cares where this one is. It just looks for the parser exactly as if it was somewhere in the open file, so the sub parser doesn't see this and doesn't care at all. Okay, not at all. It tries to parse another expression, but sees closing curly brace and says, all right, that's not my business. But until we see it, we can have anything which we already knew how to parse, and yeah, this is happening. We can just step through it, call things. Okay, Turing completeness is approaching very fast. And we have, okay, sorry, highlight. So we have if else, and I think function goes there. Yeah, so no, yeah, I think it is also like plus token 1b 31, and it's 1b 31, but how come that it's brighter? Anyway, maybe because I add yeah, these two, this is probably what I shouldn't add. 1b 33, will it be brighter? Yeah, this looks better. I think this looks better. And else and if should also look better without this. Good, and source code comes back to this parse me if you can. And function is 7 plus 9. Okay, if you can, highlight me, highlight me. If you can, function foo looks amazing, except for that we have open close, oops, and we have curly here. Okay, everything is now highlighted. So no white spots. Good, and we parse a function. Super proud. Git add, right? Yeah, this one. And parse a function. Hooray! Same mistake. Okay, sorry. Yeah, just hooray with no emotions. Or I better use it this way. Will work. Works. Hooray, hooray, finally. Great! What I can say, now back to list. So we have arg, and instead of that we should actually have args. And we don't take just one ID, we say it's an argument list. And argument list is actually this thing, arg list. So the whole thing should go, and we just do it like this. Function argument list. It doesn't require anything because it must be there, and we know it must be there. So it will just take this, then have a for loop again, and just return args. Something like this. Maybe I'll use some functional programming. That would be cool. So we have args argument list, which it's the parents around it. Should be completely fine. Yeah, so in the end, this thing would look, maybe take function, then have an ID, and then argument list, then a block, done. And it just works. We don't need to have a to compile it somehow, to have a preprocessor which understands, so it's not a macros in C. It's just plain old function. It's slow, but it's cool. Yeah, I think. So how can we do this? We just do a for loop, infinite one for now. Const id equals take id. If id, then we push it. Then we push it into args. And here we need to cover a case when it's a, comma b. So everything else must be comma b, comma id, comma id. So I think I'll start like this first. So it's a head. Remember we had heads and tails. And I coded Rust for too long, and now I like sometimes to not be too functional if it's more readable. Still, Rust is amazingly functional if you want. And here we try to do it a little bit differently. Look, here we should be maybe take ID. That's important. Yeah, because yeah, do I? Yeah, maybe take. And I don't check here. It's always, if it's a function, it has a structure. There are no maybes, but here there is a maybe. An argument list always returns an empty, at least empty array, so it cannot not return. So yeah, ID is a maybe thing, so it might be an empty list or one ID. This is what we're covering here, maybe ID. If ID, then we push it. Then we can have a maybe colon, maybe take. How we do this? Probably colon, right? We don't know how to parse colon yet. Great. Okay, so maybe take colon. If there is a colon, then there must be an ID. Const ID take ID. And then args push ID. And then again, trying to find colon. If there is no colon, then we do break. Yeah, so it's like a plus operator here. There is something on the left, and then plus B, actually plus C, then we parse it. Okay, here it's call, here we take, and always after this should be close parent expression. And about expression I'm not sure, actually not, so I think we can move it away. Should still work. No, open paren, it is kinda expression after it. So it stays here, and after it will be a block always. So when we do block, okay, yeah, I kinda can see the future. And it somehow works because there is no comma, and then comma B, ban unexpected character at source. Man, it's amazing how cool it works when you just have a good, I cannot stop loving good error messages. Whenever you build this system, if you know that the system will survive more than a month or two, try to establish, spend like a few more hours and establish a good foundation for error reporting. Whatever you do, is it a microservice, is it a game, is it your own, I don't know, language of sorts, just don't forget to respect your future self and have good error messages. So now we know exactly where the problem is, and we just go and think. Are parens like, it's paren or semicolon, right? Something like semicolon is kind of combining, and nah, I'm not sure. So semicolon, colons maybe. Yeah, something like this. So semicolon and position. So it's exactly the same. Yeah, just let's copy paste. That's, we don't need to join. And then there is a colon, which is this thing, and should be just this. All good. Yeah, a lot of copy paste probably should be take here too. Let's see later. And we have a semicolon and a colon. Colon, I think we have it more often. Yeah, so it should be here. Bam! Really? That's easy. That's simple. And we already have it. Colon goes to highlights together with this, with semicolon, I think next, right? Semicolon, first goes colon, semicolon. It's all highlighted now. If you can function, good. So far so good. I'm impressed how easy that was. A, B, and C works, and this way it will scream. It will scream? Yes. Expect token type ID, got close parent. Yes, good. And prettier knows how to parse it and just replaces it, removes it for us when we save. Good. They have a more forgiving parser than what we do. We've discussed it already. Good. Now with functions with, oh sorry, one thing I wanted to remove is, no, we need still to cover the block. Functions with, functions now with arguments. Arguments, good. And now last thing is a block. Block is more general thing. So I'd like to put it somewhere before if, I guess. So something like function block, and a block is a maybe thing because we want to reuse it. So const open, const take, if not open, maybe take, or try take, maybe take, open curly. If there is no, then we just return null. If there is, we return a block. type block, and it has this wonderful location copied. Yeah. So file open log file, start open log start, and close log start. Yeah, good. Body, and we have block body. I guess like this, and it's statements. Close, wonderful. In here, where in if later an argument list function, here we finally have const body is just a block, and we check that if no body, then we do panic. How do we do this? Panic. So let me see. Right. Okay, how we do? Expected. Okay, for okay. Expected block for function, for the function. Okay, I think this is it. Now we can remove this and it just works. Nope. Function block, sure. Block, and this one it understands this. That's good. Function block, bam, body, identifier, where. There is already body? Is there one? Yes. Oh, really? What have I done? I didn't. Remove this. Close curly is not an expression, I guess. Close curly is an expression. Anyway, I just copy pasted, right? It's all expression. Expression, yes. Oh, cool. I hover. And close. Okay. Is not defined. Really? Close, look, and where? Not here. Function statement. Yeah, sure, because it's now not close, it's the body lock end. We will proxy this thing up to there. Yeah, good. And highlighting. So actually, with the highlighting, I quickly test end-to-end test if our endings are fine, because if I do it something like this, then it just still works. 0. No one cares. Yeah. Yeah, not everything is super fine. Yeah, sure, because we don't, yeah, we use tokens, we don't use AST. Anyway, still nice to have something. And all good. Now we have the block. Let's try to have it, to use it in the if statement too. So now we can do something like this. Currently we cannot. Expected an expression and got for then, and we didn't have it. Let's try if statement, and we have then, which is statement or a block. Then pen expression, right? Bam, it just works. What can I say? We're building on shoulders of giants, and it's super readable. Try to parse statement if you cannot, try to parse block, or even block or statement. I guess that's also fine. So let's just see only this. If, then type block, which is important, maybe, because then we'll have a lexical scope, yeah, something. For the let, then type block, body, type statement, type ID. Okay, so can I then have 1 + 2, then 3 plus 2. Looks like I can block, and we have statement. Okay, 1, 2, and then locks, and then type statement, binary expression. Okay, binary expression this level 1, left, okay, right. Binary expression this level 2. Alright, numerical, Then search, there's closing else, and there is no else. What about else? Else 0. 1 else, okay, maybe 2. We have a tradition. And it all should work, else it's a statement, and then we come here and find that else should be also a block or statement. It's quite declarative what I see here. And then we have a block, and it just works. Great. Yeah, I love it. It's quite robust. Yeah, can you imagine that this is it's not a real language, but it looks like JavaScript, and we can parse it, and we almost can execute it. Not super yet, but probably good. Okay, then functions and ifs got the locks. Oopsie. Functions and ifs got blocks. Good. What else? Function calls, if you can. And then this is it. And I think function calls will be slightly harder to parse. But let's see. And we already have all the syntax for this. So we just need to implement tokens. So if we see an ID, and it is an ID, and where is ID? We maybe take ID here, where we might have, it's exactly ID, but somewhere where we have all the expression stuff, binary expression, we can have value literal, which is not anymore value literal. Sometimes it's just value things. It's like a right hand side something. I'll keep it, no, value literal is not cool, but let's have then, where do we use it? Only in value literal must. Oh, really? Yeah, should maybe make it like take, and we give the anyway, value literal, literal must have it where, have it in plus expression, then in mul expression. Good. Okay, let's extend it quickly so that if it is an ID, then we can try to parse a list. So, and then we will rename things. So if token type is an ID, then we return then we have this wonderful cool thing. Really, token next. If it is an ID, we can try to parse function function call. And let's use this technique when we really parse it and we consume it here. Yeah, I think that would be cool. So we know that this type token is an ID. We don't want to check it here again. We just want to consume it, remember it, and if it is a function call, we return a function call. If it's not, as usual, we will just return the ID. So it's an extended match. So we match an ID again, so for me to understand. We consume it and remember the ID token. Then here is another token, probably an open paren. If it is, then it is a list. Great, and a function call is actually an ID and a list, and just a list, yeah. Function list. So as far as my intuition tells me, in JavaScript you can have a list just like this, and it will be just a list of values. It will evaluate to the last one, let x equals this, and that will give you 3 as a result. And you can have here anything what you want. It's actually a list of expressions. It gives back the last expression. While when you call a function, it is almost exactly the same thing, but it evaluates not into the last position. It just gives it to the function all of the positions. I cannot immediately remember if there is anything else different. So if we implement list, we can immediately have an AST for this, and for this, no, not exactly for this, just this, and foo like this, and it will just work. So let's see where we had here. Yeah, so I think we should just have the list, function list. It's a maybe thing. So it tries to parse const open equals, how we had a block. Let's copy block. We had a block, another expression. It becomes a big thing. And inside we had statements, which is not actually. We'll have yeah, we'll have to copy a lot. So a list is kind of a block, but we have open parent, close parent, right? After open we have the expression. After this, we don't really know if it is an expression or not, and we don't have statements within. It's actually so the actual list, which we need to parse here, and type list, and type expressions. Expressions here. God, it will be a long video, sorry, but you will have all the advanced syntax in just one video if you want to sleep, and I don't know, you have a long trip, you just download this thing and you can sleep through the whole journey. Open, close, all good. And then we will have so block. I'm going there in statements. No, not this. So not a block would be the perfect. It's argument list actually. Yeah, this is what I wanted to copy. Yeah, it's argument list. Yep. Sorry. Because not the block. It is expression. Where am I? It's a green thing. List. Let me double check. It's an argument list, and then it's just list. Maybe in here instead of just ID, we will have expression. And can be list be an empty thing? Yes. This is probably the only difference. So it's an expression list, it's not just general list. Okay. So actually, yeah, we can have an empty list just floating around. Yeah, let's see, node, let x equals this, good. Let x1 equal this. Okay, of course. And then empty one, syntax unexpected token. Yeah, so it expects to have, yeah, it's a different thing in JavaScript, unfortunately. So then it's not just a list, it is an expression list. This is what we will have in our function call here. So const list, expression list. If not list, we just return the ID. Here, magic. All good. An expression list has a head, which is the first expression, and we get expression, which is a maybe thing, isn't it? Binary expression, yeah, it's a maybe thing. Good. And then if expression, then we just push it into the expressions, push expression, exper. Good. Then we have a colon. Nice. And then we have another expression. Okay, where we have an expression. Yeah, probably we can express the expression better, but not exactly now. Then it must be, if it's not colon and a valid expression, it must be a close parent. Then we just return expressions. Expression list. It always returns, and we're checking it here. Nice. This is not what we wanted. Okay, as far as we don't need this generalization, we can just merge it and have a better user experience. So we take the we try with maybe take, actually const open, maybe take open parent and then an expression, all good. If not open, return ID. Yeah, that's good. And we don't have this, and magic happens right here. And then it's a function call in the end. Then we know that we have the open parent, and within it there should be an expression. Can be an expression. So if, and we push, then surely if there is none, by the way, this is kind of a little mistake. It will still work because syntax is allowing us to it. So if there was one expression, then only we check for the colon. Yeah, maybe in some future extensions that would be important. Close parent. Yeah, good. Maybe expression, maybe it's empty. All good. Then it's a function call. That's great. Let's see where we can copy, I think from if expression, something like, yeah, something like this. It's a block. Okay. So, and then now we return a function call. Yeah, we're coming close to it. Function call. Yeah. And this is not expressions. This is arguments. Parameters. Yes, arguments actually. So there were parameters to the function. Those are actual arguments. Sorry for those who understood it and struggled so far. And what we have name, or in this case it's ID. let's use it as, so it's a name, function call name, and arguments are arguments name, and instead of the body we have arguments. It's all cool. And we have the close, const close, everything matters, and we have open close, open close, function, okay, arguments unexpected, well, strict mode, sorry, arguments, args, yeah, good, did what I wanted, nice, maybe take is not defined, maybe take, of course, maybe take, and now it works, and we have it here, block, statement, binary, numeric, no, not here, so let's look at only this one. It's in the if statement, then we have yeah, we have statement, and its expression is a function call, type ID, value can, great, name can, arguments, location is here, and no arguments. Let's have some arguments, maybe one argument. So let's simplify it. Will it work? It works, amazing. Okay, so it's an ID, can, arguments, type numeric literal 1, 2. This is where we break, unexpected character at 2, because I have a colon, if no colon then break, if there should be an expression, and of course maybe take colon, expression, unexpected here, really? So maybe take colon, then it must be an expression, expression, oh yeah. For you and me, we are very lucky that I spotted the misspelled expression, otherwise I would spend like half an hour. Yeah, TypeScript would have helped me seeing this and maybe take immediately. One day we will port it to TypeScript. Still, I'm on the edge of being efficient, but I'm still efficient. It's still not that big of a code base, but very close to it. Okay, so value 1, value 2. Let's do something inside it. 1 plus 4. And we have as an argument a binary expression. Super sweet. And we have value 1 and then plus token and then right value 4. Yeah, it works. Just works, and that's it. So this works, and probably this will also work. Yeah, it also works. So far so good. Function calls. Yeah. What's uncool is that it's a value literal, so we probably should rename it. It's not value literal. It's mostly like an expression member, something like this. Expression member, something like this. Yeah, I just don't want to rename everything. And we also have value literal must, which I don't think it's a super good thing. Just 2 places. So, or yeah, we're lying here. Expression member. Expected token type. No, it's not token type anymore. Expected expression member got token type. Expression member must, yeah, for now, okay. I'm convinced. Because I want to wrap up. Really, I want to deploy. So far so good. We do parse. Next, maybe video will be how we evaluate it. Or maybe that's what we should. That would be a big thing. So support to do. That would be really juicy. Extend lecture with conditionals, etc. So wrapping up. Yes, we did it. Maybe switch lexing mode from expression to operator. No. Syntax slider or messages. No. Bytecode. Implement some more complex exception propagation. No. Bubble like we tried with maybe something like core rewrite as in yeah, not core code, like source code rewrite as in printer. Yes, that's what I meant. So we did extend lexer and parser with conditionals, etc. That's good. And later will be actually implement closures, where we need to implement everything, implement functions, and then closures. This is what we can do. Yeah, definitely. All right, it's a very long video of 3 parts. Thank you. If you exist, a person who can watch like 4 hours of someone writing not super funny things, please write in the comment. I don't know, I'll send you a box of pizza. Good. Thank you for being here, and bye bye. See you in the stream 10.